purpose of this video is to review surface area and volume concepts and skills to get ready for our summative on Tuesday. So I'm going to look at the questions that you guys had in the feedback form for the practice summative, and I'm going to throw in a couple problems from one of our online assignments as well. So one of the first things that I would do if I were tackling this topic is I would just really make sure that I have all of the formulas down. So I'm going to start this video with just a review of the formulas. I would recommend that you also start your summative in the same way. So I'm going to ask you not to have the formula list in front of you when you sit down to do your summative. I'm going to ask you to take it as if you would in the classroom. But I would recommend the first thing you do is to take a blank piece of paper, nothing written on it, and write out the formulas. So this is a strategy that I used all the way through college. When I was getting ready for a test, is I would sit down at the beginning of a test and write down all of the things that I knew I needed to know. And it would really reduce any level of anxiety, because I'm like, okay, I've put all of my thought into coming up with this list, and now I can tackle the test without having to worry about what I might have forgotten. So again, I'm going to suggest that we start with just kind of summarizing surface area and volume for the different solid shapes that we're working with. So when we're looking at prisms, we've got rectangular prisms and triangular prisms. You guys really didn't have questions about those, but we know that the surface area is going to be the area of all the sides, of all the faces added together. And we remember that anytime we're working with the surface area of a triangular face, we have to multiply base times height times 1/2. So often it's that 1/2 piece that people just forget because they're kind of racing through it, and that can cause an incorrect answer. So surface area of prism is pretty straightforward. The volume of a prism is always going to be the area of the base. So I'm going to call that the area of the base times the height. And the area of the base is going to depend on what the shape is, but it's often base times height, or if it's a triangular prism, it's base times height times 1/2. And again, then I'm going to multiply times the height of the prism. Really, I think for prisms, it didn't seem like anyone was having trouble with that, with the exception of that we make mistakes with triangles. The next thing I'm going to look at is pyramids. So pyramids, the surface area is pretty straightforward. Again, I'm looking at all of the sides. I need the surface area, or the area of the base, and then the area of each of the sides. And usually, but not always, those 3 or 4 sides are the same. I'm sorry, I'm calling them sides. They really should be called bases. So the area of my base, the area of one of the faces, plus the area of another face, plus the area of another face, and as many of those faces as I have. For the volume of a pyramid, I find the volume of whatever the pyramid would fit in, so either a triangular pyramid or a square pyramid, but I find the volume of the prism, whatever it is, and then I multiply it times 1/3 to recognize the fact that it is a pyramid. So for example, if I had a square prism, the volume would be the base times the height times the length, or whatever you want to call those 3 dimensions, and then I would multiply all of that by 1/3. If I had a triangular pyramid, it would be the area of the base, so I'm going to call that the base times the I'm not using the word base consistently through here, so sometimes I'm using the base to refer to the whole shape, sometimes I'm using it to refer to one dimension. So I'm going to try to clean up my use of that a little bit. So I'm going to find the volume of a triangular pyramid by multiplying the length times the width times the height times 1/3, And then if there was a triangle involved, that length times the width would also be multiplied times 1/2. So sometimes when I'm looking at a pyramid, I multiply 1/2 to recognize the triangle, and then I also multiply times 1/3 to recognize that it's a pyramid. Next, I'm going to move on to cylinders, and when I'm looking at the surface area of a cylinder, I'm going to find the area of the circular base, and I'm going to multiply that times 2 for the top and bottom, and I'm also going to find the circumference of the circle, so I'm going to call that C, the circumference of the circle, times the height of the cylinder, and I'm going to add those two things together. For the volume of a cylinder, I'm going to find the area of the base times the height of the cylinder. Next up, we had cones, and you may have noticed that we did not find the surface area of cones because that kind of triangular shape is a little bit difficult to work with, and we don't need to be that advanced yet. But we did find the volume of the cone, and because a cone is a lot like a pyramid, except as it relates to a cylinder, we actually use the same formula for the cylinder, the area of the circular base times the height, and then we multiply all of that times 1/3, just like we do with pyramids as they relate to the prisms. Some of you might be saying, oh, but you asked us to find the surface area of a cone on the last problem on the practice summative. And actually I didn't. And when we get to that problem, I'll show you how you could have done that problem without needing to find the surface area of a cone. And then finally, our last shape was a sphere. And find the surface area of a sphere. So next up is the sphere, and we learned in one of the videos that the surface area of the sphere is equal to the lateral surface area of the cylinder that it would fit with inside. So we have to go back to what we know about the lateral surface area. So that was the diameter of the circle. So the diameter is 2 times the radius times pi times the height of the sphere. And we know that the height is going to be 2 times the radius because it's all the way across the circle. So our surface area is going to be 2 times r times pi times 2 times r. So 2 times 2 is 4 times pi times r squared is going to be the surface area of the sphere. Next, we learned to find the volume of a sphere, that it was going to be equal to 2/3 times the volume of the cylinder. So we go back to what we know about the volume of a cylinder, and it is the area of the base times the height. And again, we're going to multiply times 2/3 when we're done with that. The area of the base is going to be pi r squared. Again, the height is going to be 2 times r, and then we've got times 2/3. So we've got 2 r cubed times pi, and then that's all times 2/3. So 2 times 2/3 equals 4/3 the radius cubed times pi. And that's my final formula for the volume of the sphere. So now that we've started off doing almost 10 minutes worth of work before we've done a single problem, we can now tackle the problems. We've got all the formulas written down. Again, I'm going to ask you on your test not to start with them written down, not to use your notes, but to take it as if you would take it as a test in class, and start with a blank piece of paper and then write down the formulas, kind of go through in your mind how they all relate to each other. redevelop them in your mind, because this is how you're going to remember them. You're not going to remember them just by having memorized them. That would work for the test, and it's not going to work for long term. So I really want you to focus on understanding the concepts so that you can redevelop those formulas down the road when you need them. So the practice summative, the first couple problems were prisms, which we've already talked about really not needing. I'm going to start with the next problem, which are pyramids. So at this point, I'm going to put a title at the top of each little section so that if you want to skip to the next section, you can. So at this point, if you're saying, I'm totally good with pyramids, then fast forward until you see a different title at the top. But we're going to do both surface area and volume of pyramids together. So that's going to be problems 3, 4, 8, and 9 on your practice summative. So problem number 3, the surface area of my base is going to be 1.7 times 1.7. Then the surface area of each triangular face is going to be 1.7 times 2 times 1/2 because they're triangles, times 4 because there's 4 of them. So I'm going to pause for a minute and do those quick calculations. I've done the calculations and I found the surface area was equal to 9.69, but then I went back and read the directions and it said to round to the nearest tenth. So I'm going to round to 9.7 and I'm going to include a label of inches squared. You might ask, do you need to write these two things down? I would. Now, when I multiplied this on the calculator, I didn't do anything with this because I know that those cancel each other out. But if I'm writing down each piece of my work, I want to be sure that I'm multiplying times that 1/2, so I really would write this down. I'm not going to mark it wrong if you don't, but I would say always get in the habit of showing all of those steps, even the ones that you know are going to cancel each other out, so that you don't later look back at your work and say, oh, I forgot to multiply by 1/2. Next problem is number 4, so the surface area of that. So visually this one is a little confusing because they're all triangles. I always try to focus on the sides that are forming that right angle. So the surface area of my triangular base is going to be 11 times 9.5 times 1/2. And then the surface area of my faces, the slant height is 14. So I've got a 14 times 11 times 1/2. I've got a Actually, I was looking at that to see if I had a different side, but it is a equilateral triangular base, so that means all 3 of my lateral faces are the same area, so I'm going to multiply that times 3. And now I'm going to pause and do those calculations. So again, I've done this calculation, I have found my answer, and then I double check the directions and see that it's set to round to the nearest tenth, so I do that and label my answer with meters squared. Next, I'm going to move on to the volume of regular pyramids. So I'm looking at problem number 8. So I know that the area of my base is 12 times 7. And then I'm going to multiply that times the height of the pyramid, which is 9. And then that whole thing gets multiplied by 1/3 because it's a pyramid. And I'll do that calculation in just a minute. On number 9, I have a triangular pyramid, so I'm going to find the area of the base, which is going to be 12 times 15 times 1/2 because it's a triangle. Then I'm going to multiply it times the height, which is 10, and then times 1/3 because it's a pyramid. So once I have the work written down for a couple of those problems, then I'll get out my calculator and finish up the answers. I know that my labels are going to be whatever the unit is cubed. On the next video, we're going to look at cylinders, cones, and spheres. But I'm about out of time on this video, so that's going to be on video number 2.